Hello students, welcome to Aryadi classes. Today here I am teaching most important repeated examples. Okay, repeated examples for topic differentiation. Here topic differentiation. Year 23, 24, 25. Okay, most important repeated examples. Example number first, if G is the inverse of F and F dash of X is equals to 1 upon 1 plus X cube, then G dash of X is, first here given thing G is inverse of F. This is a given thing. Let us consider variable x. Therefore, g of x is equals to f dash of x. This is a given thing. Then steps are, question, find a g dash of x. Steps are, next, taking f function on both the sides. Okay. Therefore, f of g of x is equals to f of f inverse of x. Then next step is f of g of x is equals to f of f inverse of x is equals to x. Then next step is differentiating both the sides with respect to x. Therefore, we get derivative of f of g of x, derivative f dash of g of x into derivative of g of x, g dash of x is equals to derivative of x with respect to x, 1. Then next step is question, find g dash of x. Then in the left side here g dash of x. Okay, g dash of x as it is equals to 1 upon, into term becomes in the right, upon f dash of g of x. But given thing f dash of x is equals to, given thing, since f dash of x is equals to 1 upon 1 plus x cube, this is given thing. Then replacing x by here g of x, f dash of g of x, replacing x by, yes, x by g of x. Therefore, here we get, yes, therefore f dash of replacing x by g of x is equals to 1 upon 1 plus g of x whole bracket raised to 3. Correct? Then using this value, yes, using this value in equation number 1, therefore we get g dash of x is equals to 1 upon f dash of g of x value 1 upon, yes, 1 plus g of x whole bracket raised to 3. Then divided by reciprocal. Therefore, here we get g dash of x is equals to 1 plus g of x whole bracket raised to 3. Yes, option B. Yes, option B, correct option. Next example. इथे ते चेंज करू शकतात, लक्षात घ्या. इथे एक्स क्यूब असतील, एक्स स्क्वेअर असतील, एक्स रेज टू 4 रिपीटेड टाइप आहे. ओके, option B, suppose here power 2, then here g of x raised to power 2, here power x raised to power 5, then 1 plus g of x raised to power 5. Most repeated example. Next example, next example, the set of all points where the derivative of the function f of x is equals to x upon 1 plus modulus of x. Here mod given, mod x given, exists, is, options are given here. First defining mod function. Okay, f of x is equals to x upon and f of x is equals to x upon. Okay, First, if x is greater than or equals to 0, and second case, x is less than 0. X is greater than or equals to 0. Greater than 0, that is positive numbers. Yes, here x is equals to 0. Then greater than 0, that is right hand value. 0 च्या पुढे जाताय तुम्ही. Okay, x is greater than 0, positive. Therefore, mod possibility is equals to plus x. Okay, mod x is equals to plus x. And if x is less than 0, that is negative side of x-axis. Okay, less than 0, that is negative value of x. Therefore, mod x possibility 1 minus x. Okay, mod x is equals to minus x. This is our step number 1. Then derivative of the function. Okay, question derivative of the function. Then next step is we will define, okay, derivative. इथे आपल्याला काय कॅल्क्युलेट करायचं आहे? डेरिव्हेटिव्ह RHD and LHD at a point x is equals to 0. Okay, RHD means right hand derivative. Right hand derivative is equals to limit, sorry, not a limit. Okay, right hand derivative, okay, right hand derivative x is greater than 0, that is positive values. Then right hand derivative that is f dash of 0 plus. Okay, f dash of 0 plus is equals to, therefore here we get limit, yes, here x tends to 0 plus, correct, right hand. Okay, formula f of x, suppose at a point x is equals to a, and RHD, then RHD right hand, then limit x tends to a plus f of x minus f of a upon x minus a. Okay, concept. And suppose LHD means left hand. Suppose point A, then at a point x equals to a, this is our RHD, and LHD limit x tends to a minus, okay, f of x minus f of a upon x minus a. RHD, sorry, yes, RHD and LHD. Then here using that point we get limit x tends to 0 plus f of x when x tends to 0 plus f of x is equals to x upon 1 plus x minus, here a is equals to 0. Okay, f of 0 using x is equals to 0, 0 upon anything, 0 upon x minus a, x minus here a is equals to 0, then we get x minus 0 x. Solving this we get, yes, solving this we get limit x tends to 0 plus x upon, yes, x upon 1 plus x into x. Then x cancel, and then using direct method put x is equals to 0, put x is equals to x cancel, x is equals to 0, 1 upon 1 plus 0, 1. This is our part first. Okay, then next part LHD is equals to limit, that is left hand derivative, at which point x is equals to 0. Yes, limit x tends to 0 minus, formula f of x minus f of 0 upon x minus 0. Limit x tends to 0 minus, yes, f of x is equals to, when x is less than 0, then function x upon 1 minus x, x upon 1 minus x, x upon 1 minus x minus f of 0, using x equals to 0, f of 0, 0 upon 1 minus 0, 0 upon anything, 0. Yes, here we get 0 upon x minus 0x. Therefore, here we get limit x tends to 0 minus x, x cancel, 1 upon 1 minus x. And then using direct method put x is equals to 0, 0. कॉमन टर्म जेव्हा कॅन्सल होते, लिमिटमध्ये तुम्हाला पॉईंट माहीत असेल, कॉमन टर्म कॅन्सल झाली की स्टेप असते युजिंग डायरेक्ट मेथड. देअरफॉर x कॅन्सल, using direct method put x is equals to 0, 1 upon 1 minus 0, 1. Therefore LHD 1 and 1 both values are same. Yes, therefore LHD is equals to RHD at which point x is equals to 0. Yes, that for left hand derivative is equals to right hand derivative at which point x is equals to 0. Therefore, at x is equals to 0, therefore, f of x is equals to x upon 1 plus mod x exists is option A, open interval minus infinity to plus infinity. Okay, differentiable function in this interval minus infinity to plus infinity. Here option is A. Option A, correct option. Option A, correct. Yes. Next example. Next. y is equals to cube root of 1 plus 3x. Cube root means raised to 1 by 3. Yes, cube root means raised to 1 by 3. Fourth root means raised to 1 by 4. 1 plus 4x raised to 1 by 4. Yes, into. Fifth root means 1 plus 5x raised to 1 by 5. 1 upon 5. Whole divided by 7th root of 1 plus 7x given here. Therefore, 1 plus 7x raised to 1 by 7 power. 1 by 7 into 8th root of 1 plus 8x. 1 plus 8x raised to 1 by 8. Question, find dy by dx at which point x is equals to 0. Here our steps are 1 plus 3x raised to 1 upon 3 into 1 plus 4x raised to 1 upon 4 into 1 plus 5x raised to 1 upon 5. And 1 plus 7x raised to 1 by 7, we know that 1 upon a raised to plus m is equals to a raised to minus m. Therefore, 1 upon 1 plus 7x raised to 1 by 7, that is 1 plus 7x raised to minus 1 by 7. Similarly, 1 plus 8x raised to minus 1 by 8. Okay, quotient of number of functions, or another method, taking log on both the sides, then using log rules, and then differentiation. Okay, then next step is differentiation, differentiating both the sides with respect to x. Therefore, dy upon dx, yes, dy upon dx is equals to derivative of first into product of 4 terms, as it is derivative of first. We know that product rule, d by dx of u into v, u into dv by dx plus v into du by dx. Similarly, but here terms are 4, 5. 1, 2, 3, 4, 5. Yes, derivative of first, derivative of 1 plus 3x raised to 1 upon 3 derivative, 1 upon 3 into 1 plus 3x raised to 1 by 3 minus 1, 1 by 3 minus 1, 1 minus 3 minus 2 by 3 into derivative of 1 plus 3x, 1 derivative 0 and derivative of 3x 3 into product of 4 terms. 4 remaining terms, 1, 2, 3, 4 remaining terms, then plus first as it is, third term as it is, fourth term as it is, fifth term as it is, derivative of second, 1 plus 4x raised to 1 by 4, 1 by 4 into 1 plus 4x raised to 1 by 4 minus 1, 1 by 4 minus 1, 1 minus 4 minus 3 by 4 into derivative of 4x, 4 into product of 4 terms. Next, plus first as it is, second as it is, derivative of third. Yes, 1 plus 5x raised to 1 by 5, 1 by 5 into 1 plus 5x raised to 1 by 5 minus 1, 1 minus 5 minus 4 by 5 into derivative of 1 plus 5x, 1 derivative 0, 5x derivative 5 into product of 4 terms, plus continuing the process. Continuing the process we get, म्हणजे ही process जर continue केली, first, second, third, in the last 2 parts we get, yes, first, second, third term as it is, 1 plus 7x raised to minus 1 by 7, it's a derivative, yes, minus sign here, yes, minus 1 upon 7 into 1 plus 7x raised to minus 1 by 7 minus 1, -1 -7 -8/7. Correct? -1/7 -1 -8/7 into derivative of 1 plus 7x into 7 plus into minus minus last part last into product of yes remaining 4 terms. Similarly last म्हणजे तुम्ही पहिली टर्म आणि बाकी टर्मचा अंदाज येतो की इथे साइन मायनस येते इथे मायनस येते त्यामुळे हे -1 ची टर्म ह्या +1 ला परत ही मायनस ची टर्म ह्या +1 ला कॅन्सल होते कारण लास्टला तुम्हाला x = 0 पुट करायचे आहेत. ओके त्यामुळे आन्सर 1 येतं. 1 1 + 1 + 1 -1 -1. ओके आन्सर +1. लास्ट part last -1/8 into 1 plus 8x raised to -1/8 -1 -1 -8 -9/8 into derivative of 8x8 into product of yes remaining terms. This is our derivative. Then next put x is equals to 0. X is equals to 0. At x is equals to 0 we get yes 0 0 1 plus 0 1 raised to anything means -2/3. 1 ची पॉवर किती जरी असली तरी आपण 1च घेतो आणि निगेटिव्ह पॉवर असेल तर आपण अपॉन मध्ये ऍडजस्ट करून प्लस करू शकतो होय की नाही बरोबर. मग इथे तुम्हाला काय मिळेल हे आणि टर्म कॅन्सल होतात into 3/3 4 4 कॅन्सल 5 5 कॅन्सल 7 into 7/7 कॅन्सल into 8/8 कॅन्सल. देअरफॉर हिअर वी गेट +1. ही टर्म येणार आहे तुमची 1च येणार आहे. ओके 1 इथे पण तुमची ॲट x = 0 ला हे 1च शिल्लक राहणार आहे म्हणजे +1 +1 +1 +1 plus into -1 at x = 0 using x = 0 and last -1. Therefore here we get +1 -1 +1 -1 cancel answer 1. म्हणजे orally सुद्धा तुम्ही सॉल्व करू शकता. yes next example using here shortcut method y is equals to under root of x minus sin x plus under root of here whole root of given. Okay we know that shortcut y is equals to under root of f of x plus under root of f of x plus continuing the process. Okay then shortcut dy upon dx is equals to f dash of x upon 2y minus 1. Therefore here we get dy upon dx is equals to okay this is our f of x function. 1 minute. This is our function f of x. Yes f of x derivative of x 1 and derivative of sin x f dash of x that is derivative of x minus sin x. याचं डेरिव्हेटिव्ह काढताय तुम्ही म्हणजेच f dash of x x derivative 1 sin x derivative cos x whole divided by 2y minus 1 as it is option yes option A. Okay option A correct. Next example next y is equals to a sin x repeated example a sin x plus b cos x where a and b are constants. Then y square plus dy by dx whole bracket square is a function of x and y, a function of y, a constant option. ओके कॉन्स्टंट स्टेप्स आर म्हणजे इथे ते टर्म चेंज करू शकतात लक्षात घ्या. y is equals to first you're going to find out dy by dx differentiating with respect to x. Here a and b these two are constants. Differentiating we get dy upon dx is equals to a as it is derivative of sin x cos x, b as it is derivative of cos x minus sin x minus into plus minus sin x. Okay this is dy by dx. Then next step is question y square plus dy upon dx whole bracket square is equals to y square y is equals to a sin x plus b cos x. Okay this is y then its square plus dy by dx is equals to a cos x minus b sin x whole bracket square. Then solving this we know that a plus b whole bracket square expansion a square plus 2ab plus b square Therefore, here we get a square sin square x plus 2ab sin x into cos x plus b square cos square x. Then here like a minus b bracket square expansion a square minus 2ab plus b square. Here we get plus a square cos square minus 2ab minus into plus minus 2ab sin x into cos x plus into plus plus b square sin square x. Therefore, here we get, yes, here we get 2ab sin x cos x minus 2ab sin x cos x term cancel. Then a square sin square plus a square cos square, taking a square common, bracket sin square x plus cos square x. Yes. Then b square cos square plus b square sin square x, taking b square common, bracket cos square x plus sin square x. Then by identity, sin square plus cos square 1, cos square plus sin square 1. Therefore, answer a square plus b square. Okay, a square plus b square, constant term, constant. Option D. Option D. Option D. The next example. Next example. F of x is equals to cos inverse of x. G of x is equals to e raised to x. Question. H of x given. H of x. Composition of two functions. F of x, g of f of x given. Question. H dash of x upon h of x. First, here we have to find out h of x. H of x is equals to g of f of x. Composition of two functions given. Steps are h of x is equals to, start from right side. इकडून यायचं. Start from right side. G as it is. Using here f of x is equals to cos inverse of x. Cos inverse of x. Put f of x is equals to cos inverse of x. H of x as it is. Then we know that g function, yes, g of x is equals to e raised to x. Then replacing x by here, replacing x by cos inverse of x. G of cos inverse of x is equals to e raised to cos inverse of x. Yes, e raised to cos inverse of x. म्हणजे आधी फंक्शन डिफाइन करा h of x, then it's a derivative. Then derivative of h of x differentiating with respect to x, we get h dash of x is equals to derivative of e raised to x, e raised to x. Here derivative of e raised to cos inverse of x, e raised to cos inverse of x into derivative of cos inverse of x minus 1 upon under root of 1 minus x square. This is value of h dash of x. Question. H dash of x upon h of x is equals to h dash of x value e raised to cos inverse of x into 1 upon under root of 1 minus x square whole divided by h of x. H of x is equals to value e raised to cos inverse of x. E raised to cos inverse of x term cancel. Therefore, answer 1 upon under root of 1 minus x square. Option, yes. 1 upon under root of 1 minus x square with minus sign, sorry, with minus here, minus and here also minus. Okay, option A correct? Yes, option A correct. Option A. Next example. Y is equals to sin x upon 1 plus cos x upon 1 plus sin x upon 1 plus. आता इथे एक लक्षात घ्या, टर्म्स रिपीट कुठून होत आहेत ते समजून घ्या. रिपीट म्हणतीये मी. ओके, sin x as it is upon 1 plus cos x. इथे कुठे रिपीट होत नाहीये, होय की नाही? sin x upon 1 plus cos x upon 1 plus. इथून रिपीट होत आहेत. हे बघा इथे sin x आहे का, इथून सुरुवात जी आहे ना तिथून बघायचं. रिपीट होते का बघा, sin x प्लस कॉस ऑफ sin x प्लस कॉस ऑफ इज इक्वल्स टू y. इथे मी y पुट केले. टाइप रिपीट होत आहेत, इम्पॉर्टंट आहे, लक्षात घ्या. देन नेक्स्ट पार्ट, इन द डिनॉमिनेटर cross multiplication. Therefore here we get question find dy by dx. Therefore y is equals to numerator as it is sin x. In the denominator cross multiplication, 1 into 1 plus y, 1 plus y plus cos x whole divided by, yes, 1 plus y, then divided by divided reciprocal into 1 plus y. Yes, then next step is differentiation. Then next part derivative. डेरिव्हेटिव्ह इथे आपल्याला घ्यायचं आहे, किंवा काही जण म्हणतील अपॉनचे इंटू केले तर चालेल का, तर येस चालेल. अपॉन टर्म बिकम्स इंटू. ओके, देअरफॉर y इंटू 1 प्लस y प्लस कॉस एक्स इज इक्वल्स टू sin x इंटू sin x इंटू 1 sin x प्लस y इंटू sin x, y इंटू sin x. काय केलं मी इथे, डिवायडेड बाय डिवायडेड क्रॉस केल्यानंतर न्यूमरेटरला घेतले आणि इथं आतमध्ये मल्टिप्लाय केलं, 1 इंटू sin x प्लस y इंटू sin x. देन नेक्स्ट स्टेप इज मल्टिप्लाइंग बाय each by y in the left side. Okay, therefore 1 into y plus y into y square plus y into cos x is equals to sin x plus y sin x. Then next part, differentiating with respect to x. This is implicit type. Yes, implicit steps are first differentiation and then combining dy by dx terms in the left side and non-dy by dx terms in the right side. Okay, then derivative of y with respect to x, dy by dx. Derivative of y square, 2y into dy by dx plus y cos x derivative by product rule, y into derivative of cos x minus sin x plus cos x as it is into derivative of y, here using u into v. Okay, derivative of y with respect to x dy by dx equals to derivative of sin x cos x plus, here also using product rule y into derivative of sin x cos x, okay, plus sin x as it is y into cos x derivative of sin x cos x plus sin x into derivative of y with respect to x dy upon dx. Okay, then next step, combining dy by dx terms in the, yes, dy by dx terms in the LHS page आहे का, yes आहे. Combining dy by dx terms in the LHS 1 2 3 and 4 and taking dy by dx common. Yes, coefficient of dy by dx 1 plus 2y plus cos x and plus sin x in the left side becomes minus sin x. And non-dy by dx terms in the RHS, त्या राईटला येऊ दे. Okay, cos x plus y cos x plus y cos x, then yes, next plus into minus y sin x plus, sorry, minus term in the right becomes plus y sin x, yes, option, and into taking dy by dx common. Therefore dy upon dx is equals to, yes, sequence, option, sequence, we are taking common. Okay, common given, here taking common part, option, minute, y sin x plus, first right side as it is, cos x plus y sin x, sorry, y cos x plus y sin x, yes, whole divided by, into term becomes upon 1 plus 2y plus cos x minus sin x, yes. Therefore dy upon dx is equals to denominator 1 plus 2y, 1 minute, 1 plus 2y प्लस कॉस एक्स मायनस साइन एक्स इन ईच अँड एव्हरी ऑप्शन गिवन. प्रत्येक ऑप्शन मध्ये आहे की नाही? आहे. मग आता तुम्हाला इथे काय कॉमन दिसतंय का बघा, वाय साइन एक्स प्लस 1 प्लस वाय कॉस एक्स होऊ शकतं का रे मुलांना? होऊ शकतं. ओके, इथे हे कॉमन घेतलेले आहेत. येस, वाय साइन एक्स प्लस कॉस एक्स कॉमन, कॉस एक्स कॉमन 1 प्लस वाय अपॉन 1 प्लस 2y plus cos x minus sin x. This is our correct answer. Okay, this is our correct answer. Okay, thank you.